Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. Uh, Happy to meet you again today. Uh, so, so we'll continue with our Module 2 Physics. Currently in our topic is in Chapter 2. Chapter 2, Kinematic. Before that, we try to revise back what we have learned in the previous slot 4. Previously, we have studied mechanics, statics, and then currently the slot 5 and slot 6 is about kinetic. Kinematic. Okay. Previously, you have learned about buoyancy in liquid. How do a ship float lah? Macam mana satu ship can be float, or how a heavy metal can float on our sea or water. So if we throw a rock into the water, we will see that the rock will submerge ataupun immerse into the water. The rock will immerse into the water ataupun akan tenggelam lah. Batu akan tenggelam ke dalam air lah. Tapi macam mana suatu kapal yang berat, satu kapal yang diperbuat pada besi boleh timbul di atas air lah, It come from the buoyancy principle ataupun Archimedes principle lah. Okay, Archimedes principle, what he say that the upward buoyant force that is exerted on a body immersed in a fluid. So dalam Archimedes principle dia kata ada satu force yang dinamakan sebagai buoyant force which support the ship to float lah. Dia yang support ship to float lah. Whether partially or fully submerged is equal to the weight of fluid that been displaced and act in upward direction at the center of mass of the displaced fluid. Okay, so Archimedes principle cakap ada satu force when satu objek, contohnya kapal, is partially ataupun fully submerged into water, ada satu force tu yang sama, equal to the weight of fluid that had been displaced. Satu force tu yang support kapal tu is equal to the weight of the fluid that body been displaced. Itu ialah buoyancy ataupun kita namakan buoyant force lah. It come from the Archimedes principle lah. So dalam topik sebelum ni kita telah belajar tentang Archimedes principle. If you forget about the topic, you can try to look back at the video that have been attached in our platform. Okay, so for today we learn about kinematic. Kinematic. Mekanik kinematik. Yang tu ada typing error sikit, ada typo error. Bukan kinetic ya, kinematic. Okay, what is kinematic? Kinematics ingat, kinematics all about what is kinematic? Kinematic is one of the branches of mechanic lah. Salah satu cabang mekanik dalam subjek. Kita tahu mekanik kita ada static, kinematic, dynamic and fluid motion. Kita ada 4 cabang. So one of that is kinematic lah. One of cabang of mechanic is kinematic. Selain daripada static, kinematic, dynamic and lastly ialah fluid motion. Okay, kinematic of one branch of mechanic lah. It deal with the motion of particle, not the cause of motion lah. It deal with motion of particle, not the cause of motion. Kita study tentang motion of particle, tapi bukan sebab yang menyebabkan pergerakan. Kita study tentang motion of particle. Motion in one dimension, in other words, linear motion lah. Kita study tentang linear motion and projectile motion are suitable of kinematic. They are also called as 1D or 2D. Kita study tentang motion of object dalam linear ataupun 1D or 2D, bukan dalam 3D motion, dalam 1D ataupun 3D. Some mathematical symbol, equations and graphic will be used to show the relation of basic concept lah. Okay, now it's time up to get fun with physics lah. Kita akan tahu apa lagi yang terlibat. This subject will convert this unit lah. So dalam kinematik topik kita akan learn about distance, jarak, displacement, seseran, speed, velocity and acceleration ataupun pecutan. Kita akan belajar tentang semua quantity of physics yang berkaitan dengan ukuran ataupun linear motion ataupun dalam 1D ataupun 2D. Dalam kalau kita tengok slide, describe motion of point, bodies, object and system of bodies, group of object without considering the cause of motion. Kita tak study penyebab pergerakan, tapi kita study pergerakan tu, jarak dia tu. Kita tak study force yang menyebabkan pergerakan, kita tak study. Kita study tentang pergerakan tu, sama ada speed dia, velocity dia, acceleration yang kita study. Itu makna kinematik, one of branch of mechanics. Okay, dalam kinematik kita akan belajar tentang distance, displacement, speed, velocity and acceleration. So ada 5 quantity of physics that we need to learn. Kita akan belajar ada 5 perkara. Okay, yang first is distance. Apa itu distance? Okay, distance is a linear movement lah. Linear movement, uniform straight line lah. It's a scalar quantity. Dia hanya ada magnitude. It's a scalar quantity ya. Okay, representing the interval between 2 point lah. Dia representing interval ataupun jarak between 2 point in a linear motion. Okay, itu distance. Itu distance. Satu lagi ialah displacement. Apa itu displacement? Displacement kalau dalam bahasa Melayu kita panggil seseran. Kalau dalam bahasa distance tadi jarak. Yang ni displacement ni seseran. Ialah vector quantity which is dia ada magnitude and also direction. Dia ada magnitude and also direction lah. Defined as a distance between the initial point and the final point of object. Jarak di antara initial point, point asal kepada point akhir dia. Dia tak kira jarak yang dilalui dia kira jarak paling dekat di antara point asal dan point akhir. Dia bukan kira jarak keseluruhan. Dia kalau jarak kita daripada masjid tu akan lalu bengkok sebelum sampai ke masjid tu, dia bukan kira jarak tu. Mungkin kalau jarak tu mungkin 10 km. Tapi kalau jarak pendeknya daripada satu point ke masjid tu, mungkin kalau kita ambil pembaris, kita gariskan satu garis lurus, mungkin 5 km. So dia kira jarak yang terdekat, shortest distance. Dia tak kira jalan, dia kira jarak terdekat. If you see in the picture in the slide, you can see that a bicycle lah, a boy driving cycling a bicycle from point A to point B and lastly to point C lah. So kalau total out the distance, kalau kita ambil distance dia, itu jarak dia 4 meter plus 3 meter. So the total is 7 meter lah. But in this case, we calculate displacement, seseran, jarak, the shortest interval connecting the initial point to the final point. That in a straight line, dapat 5 meter. So jarak yang terdekat ialah 5 meter displacement. Okay, what about speed? Okay, another quantity, the third quantity of physics is speed lah. Apa itu speed? Speed defined as how fast something moves lah. How fast something moves. Scientifically as a distance cover in a unit of time lah. Kalau dalam bahasa scientific dah atau fiziknya, distance cover in a unit of time. Berapakah jarak yang di cover dalam per unit masa, It's a scalar quantity because dia tak ada arah, dia have arah, dia hanya ada magnitude, dia tak ada direction. Unit in ms -1. Okay, distance kalau dalam formula s ataupun speed in formula is equal to distance over time lah. Speed is equal to distance over time. It's a scalar quantity. Okay, what about velocity? Okay, velocity is a vector quantity. Is speed having a direction lah. Ialah speed having a direction. Dia ada direction lah. Sebab vector quantity which have magnitude and direction. In a daily life, we use speed and velocity interchangeably. But in physics, they have different meaning lah. Kadang-kadang kita tertukar laju dengan hal laju ataupun laju dengan hal laju, jarak dengan seseran, kita main campur aduk. Tapi dalam fizik, they have different meaning lah. Other definition of velocity as the rate of change of displacement lah. Rate of change of displacement lah. Whereas the speed is the rate of change of distance. Beza dia punya takrifan lah. Satu rate of change of displacement, seseran. Ini satu lagi the speed is the rate of change. Kadar perubahan jarak dengan kadar perubahan seseran berbeza. Unit dia sama dengan speed juga, velocity ms negatif 1. So the formula for velocity is equal v is equal to s over t lah. S is displacement lah. S is displacement. Okay, the last quantity physics we'll study in kinematic. Oh, before that, we go to a question. An example, a man traveling with car. His car 150 meter to the east and then 70 meter to the west. First dia pergi east, dia pergi timur dulu. Dalam ni, timur dulu. Okay, dia pergi timur dulu 150 meter and then to the west 70 meter. Calculate the average speed and velocity of the car if the travel take 10 seconds. So 150 meter ke kiri. Okey, 150 meter ke kiri dan ke kanan lah. Okey, kena beza lah. Kita nak calculate speed dengan velocity. Apa maksud speed? Apa maksud velocity? Speed is rate of change of distance. Velocity is rate of change of displacement. Kalau velocity kita kena ambil 150 minus 70 sebab first dia pergi ke east 150. Lepas tu dia patah balik 70 meter ke west. So 150 ke kanan and then tolak 70 ke kiri. So 80 lah jarak dia. Displacement dia ialah 80. 80 per 10 dapat 8 meter per second. Dapat 8 meter per second. Kalau speed pula, dia adalah rate of change of distance. Jarak keseluruhan. So jarak keseluruhan 150 tambah 70 bagi 10. Dapat 22 meter per second. Okay. Boleh ya? If any question, you can PM me through the platform. Okay, the last quantity of physics that we will learn is acceleration lah. So what is acceleration? Okay, acceleration defined as change in velocity, rate of change in velocity. Velocity itu ialah hal laju. Okay, vector quantity, kalau velocity pun ialah vector quantity, confirm lah acceleration pun vector quantity lah. Unit for acceleration are ms negative 2 lah. Power of negative 2 lah. Okay, change in velocity per 8. Kalau rumus dia, acceleration, symbol dia A, acceleration, small a, equal to change in velocity, velocity final minus velocity initial over time ya. Itu formula dia. So, kita tengok example. Example, kita ada a car start to move. Ingat dia kata start to move. Bermula, baru nak gerak. Move and reach the velocity 80 meter per second. So dia start tu from zero lah. Start from zero to move and reach 80 meter per second lah. In 10 second, calculate the acceleration. So V final dia ialah 80 meter per second and V initial dia is 0 lah. So 80 minus 0 divide by 10 is equal to, tak nampak, is equal to 8 meter per second ataupun 8 meter per second power of negative 2 power of negative 2. Okey boleh. Okey, kita akan tengok satu video daripada Department of Electronic and Info Technology, Amrita University. Credit to them for this video.
One-dimensional motion. As we look at our surroundings, we will find many objects at motion and many at rest. In a real sense, motion and the state of being at rest are profound topics. Let's try to have a better understanding of these subjects. Consider a man sitting in a park as a squirrel runs by him. The man is at rest with respect to his surroundings. The squirrel is in motion with respect to the man. Now, consider the earth and the moon. With respect to the moon, the earth is in motion, and so the man is also moving. Here, the moon is a frame of reference. Therefore, an object is said to be in motion if there is a change in the position of the object with respect to the frame of reference. So far, we've discussed motion and frame of reference. Let's now understanding the meaning of distance and displacement. A bus moves from destination A to destination B. In its course, it changes its direction constantly and reaches destination B. In the process, the bus has covered a distance of 2000 meters. The length of the path covered is called distance d travelled. Here the moving body has only magnitude, no direction, and hence distance is a scalar quantity. Now, let us consider that there is an alternate route which takes the bus to the destination B in the shortest distance, that is 1500 meters. The straight distance between the initial and the final positions of a moving body in a particular direction is called its displacement. Here, the moving body has magnitude in direction. Hence, displacement is a vector quantity. Let's now discuss speed and velocity. Speed is the distance travelled by a body in unit time. Consider an object moving from destination A to destination B at a certain time t, that is 600 seconds. The distance d between the point is 2000 meters. Let's calculate the object speed. Speed is equal to distance d by time t. 2000 by 600 is 3.3. The SI unit of speed is meter per second. This is represented by the symbol ms to the power of -1 or m/s. When we calculate the displacement of the object between the same points per unit time, we will obtain its velocity. That is, velocity is the rate of change of displacement. So velocity v is equal to displacement by time. That is, 1500 by 400 is equal to 3.75. The SI unit of velocity and speed is meter per second. What happens when a body moving in a certain direction changes its speed suddenly? Let's consider two vehicles moving in parallel with uniform velocity, that is 10 meters per second from point A to point B. Suddenly, one vehicle increases its velocity, that is 15 meters per second in 3 seconds, and speeds off towards point B. As the velocity of the vehicle has increased, it is said to have accelerated. Acceleration is calculated as the rate of change of velocity. That is, acceleration A is equal to change in velocity by time. Here, change in velocity is 15 meters per second minus 10 meters per second, which is 5 meters per second. T is equal to 3 seconds. Therefore, acceleration A is equal to 5 by 3, which is 1.6 meters by second square. Things to remember. Motion is the change in position of an object with respect to a frame of reference. The length of the path travelled by a moving object is called distance. Distance is a scalar quantity. Displacement is the distance travelled by an object with a certain magnitude. Displacement is a vector quantity. Speed is the distance travelled by a body in unit time, and velocity is the rate of change of displacement. The SI unit of velocity and speed is meter per second. Acceleration is calculated as the rate of change of velocity. The SI unit of acceleration is meters by second square.
Okay, we continue. Okay, we have seen the video all about distance, displacement, velocity, speed and acceleration. So when we discuss about a body moving in a straight line, then we do not have any chance in any change in direction lah. So kita study about motion dalam straight line dan kita tidak consider any movement yang luar pada straight line lah. In this instant, any acceleration is due to change in speed. Special formula which deal with straight line motion use certain symbol to present specific quantities. These symbols are summarized as below lah. So daripada all the acceleration, velocity, speed, distance and displacement, physics have come up with several linear motion formula lah, as per in the slide lah. You can see in the slide, the first formula S is equal to U plus V divide by 2 times T. S sama dengan U tambah V per 2 darab dengan T. The second formula V is equal to U plus AT. V samakan dengan U tambah AT. S is equal to UT plus half AT power of 2. S sama dengan UT tambah setengah AT kuasa 2. V kuasa 2 equal to U kuasa 2 tambah 2 AS. All of these four formula is equation for motion along a straight line. For a motion along a straight line lah. Note that S in the tradition notion for distance is all dekat dalam ni. S is about seseran ataupun displacement lah. A is acceleration, T is time, U is initial velocity, V is final velocity. So ini adalah equation for motion along a straight line. Kita tahu kinematic, we doesn't study the cause of motion in the straight line. Kita study tentang motion of straight line, motion of an object in a straight line. So tadi kita belajar tentang pergerakan linear motion. Okay, now kita belajar tentang a linear motion juga, tapi in different direction. Tadi in a horizontal ataupun mendatar, linear in mendatar. Sekarang vertical punya, free fall. Tapi in a straight line also, kita panggil straight line motion, is under motion under gravity punya effect. Okay, free fall. A free fall is a kind of motion that everybody can observe in daily life lah. Kita angkat ni contoh ni, jatuh. Kita angkat kita punya pemadam, jatuh ke bawah. It's a free fall lah. Salah satu daripada konsep free fall. Saya ada video. Okay, we drop something accidentally or purposely, we can see the motion of free fall lah. At the beginning, it has low speed, and until the end, it gains speed, and before the crash, it reach the maximum speed. So pada awalnya dia perlahan, lama-lama makin ke bawah dia gain speed, dia akan bertambah laju, and then paling sebelum dia stop atas tangan ni, paling dekat tu ialah the maximum speed dia before dia reach dekat bawah tu. Itu maximum speed dia. Atas ni zero, bergerak perlahan, makin laju, paling laju dekat sebelum dia cecah lantai. Itu paling laju. Okay, gravitational acceleration is shown as G lah. Kalau tadi kita guna acceleration A, dia punya simbol as A, tapi untuk gravitational acceleration ataupun tarikan pecutan graviti, kita ambil value dia sebagai simbol dia sebagai G lah. And the value selalunya 9.81 ms power of 2 lah. Tapi dalam fizik sometimes we assume as 10 lah. for a simple calculation. For a simple calculation, we use the value is as 10 lah. 10 m per s power of 2 . Okay, thus to solve any equation, we can use equation for a motion of straight line with replacement of acceleration lah. So kita boleh guna rumus linear motion tadi tu kita belajar ya, ada 4 linear motion punya formula tu. S is equal to u t plus a t power of 2 v power of v kuasa 2 sama dengan u kuasa 2 tambah 2as. Kita boleh guna semua tu untuk free fall punya motion in a straight line. But only we replace the value of A dekat dalam linear motion tu, acceleration, to G, gravitational motion, acceleration. Free fall. Tengok macam mana bulu ayam tu. Free fall. So, not pen. Berbeza tak dia punya free fall punya speed. So, dia punya acceleration pun berbeza. So, kat sini kita gunakan 4 formula yang sama. The same 4 formula for linear motion. But, we replace A dengan G. Gravitational acceleration. Okay, example question for free fall. The example you can see in the slide ataupun dalam unit textbook pun ada. The boy drop the ball from a mountain cliff. Seorang budak jatuhkan bola daripada hujung sebuah mountain, sebuah gunung, which take 3 seconds to hit the ground. Yang ambil masa 3 second untuk hit the ground. Sekejapnya. Calculate the velocity before the ball crash to the ground lah. G kita ambil gravitational acceleration, kita ambil 10. So kita ada apa? Kita ada time T 3 second, kita ada G gravitational acceleration 10, dan kita ada U initial velocity dia kosong. Initial velocity. Tapi calculate the velocity before the ball crash. Kita nak calculate velocity final dia, V dia. Okay, kita gunakan linear motion punya formula. V is equal to U plus GT. So V equal to 0 plus 10 minus 3 multiply by 3. So kita dapat 30 meter per second. 30 meter second negative power of 1. Okay, simple aja. So kita pergi the next question. Okay, the next question sama juga untuk free fall. John throw the ball straight upward 1 second and it reach its maximum height. Then it does a free fall motion which take 2 seconds. Calculate the maximum height and velocity of ball before it crash to the ground. So macam mana kita nak calculate the maximum height? Okay, kita ada apa? Kita ada 1 second. Untuk maximum height tu kita ada 1 second. Kita ada 1 second. Time dia kita ada 1 second. Kita ada G. Kita ada U. U sebab kosong asalnya. So kita guna V, U tambah GT. So kita dapat hal laju dia, final velocity dia 10. So kita tahu the final velocity tu adalah the maximum dia boleh pergi. Dia akan berhenti kan. Kita baling atau bola, hop. Jadi dekat atas tu, sebelum dia berhenti tu ialah the maximum height. Ini maximum height. Ini maximum height sini. So sebelum dia berhenti tu ialah maximum height. Jadi kita dapat velocity final dia, velocity paling laju dia. So kita guna rumus S is equal to UT plus half GT kuasa 2. So kita calculate masuk rumus kosong tambah setengah 10 T kuasa 2. So kita dapat S is equal to 20 meter. Okay, and then kita calculate untuk velocity of the ball before it reach the ground. So kosong tambah negative 10 darab 2. So dapat negative 20 meter per second. Kenapa dapat negatif? Sebab kita anggap direction dia berbeza. Ke atas tu positif, ke bawah tu negatif. dapat negatif 20 ms negatif 1. So any question, if you have any inquiries, you can let me know through our chat in the platform ya. Okay, kita move on to circular motion. Okay, rotation motion mean motion involving curve lah, involving curve path. Therefore, change of direction lah. Bila kita main motion, tadi kita belajar dalam straight line. Sekarang kita belajar dalam circular motion. Circular motion. Again, only cases of constant acceleration. Kita ambil kira constant acceleration are considered here. Cases involving linear transition and rotation are definitely ignore lah. Kita tak involve in calculation linear plus rotation. Kalau linear kita calculate linear, rotation kita calculate rotation with constant acceleration. So tadi kita belajar tentang linear motion. Rumus dia kita ambil balik, fizik lah buat formula yang sama juga. W tu awak tengok dalam slide ni, omega tu is a velocity. So W2 tu ialah final velocity, W1 ialah initial velocity. Alpha is equal to acceleration. Alpha tu macam ikan tu, alpha tu is equal to acceleration. T is equal to time lah. Theta is dia punya distance, angular displacement. Theta yang bulat tu macam zero tu, macam O tu ialah displacement ataupun distance ataupun displacement lah. Itulah. Tapi dalam angular, dalam curve motion, So calculation dia jarang keluar sebab in AN1101 physics for circular motion ni ialah level 1 lah. You should only know about it. It doesn't require you to know the calculation and deep towards the analysis of this motion. Ini contohnya, okay, tengok perbandingan sama linear motion dengan rotational motion. Okay, ini centripetal force. Okay, what is centripetal force? Apa itu centripetal force? Okay, consider a mass moving at a constant speed v but following a circular path. Kalau awak tengok ni, kereta tu contohnya dia bergerak dalam constant speed, dalam 80 km per second, but in circular path. At one instant it position A and constant V. Kalau awak tengok gambar rajah tu, the force that pull an object out of a straight line path into a circular orbit is called centripetal force. Centripetal force yang tarik awak ke dalam. Awak contohnya, awak ada mouse ni, contohnya ada bola lah pada ujung ni. Bola ni awak rotate dia. Rotate ni kan. Force yang ke dalam tu, ke dalam mouse ni, yang bergerak ke dalam kan. Yang bergerak ke dalam pusat, silap ke dalam mouse pula. Ke pusat ni, pusat yang saya tangan jari saya ni, pusat ni, yang bergerak ke pusat ni ialah centripetal force. Yang menolak mouse ni keluar ialah centrifugal force. Ke dalam centripetal, keluar centrifugal force. Boleh? Rumus dia tu, centripetal force M times V kuasa 2 over R lah. Ini pun tak ada calculation. We don't worry about it. Okay, centrifugal force, Newton's third law state we know that if a force act on stone, when there must be an equal and opposite force acting on anybody. So, opposite of centripetal force adalah centrifugal force. Centrifugal force yang menyebabkan awak rasa nak tercampak keluar. Bila kereta awak berpusi pada keadaan selekoh yang tajam kan, awak rasa nak tercampak keluar. Itu disebabkan oleh centrifugal force. Yang tarik awak ke dalam kereta itu ialah centripetal. Contoh tangan ada, ayah awak tengah drive, awak rasa nak terpelanting, ayah awak tarik awak. Yang tarikan ke dalam tu dipanggil centripetal force. Keluar tu ialah centrifugal force. This will be force on the hand holding the string and this known as a centrifugal force. Centripetal force ke dalam. Centrifugal force yang menyebabkan awak rasa nak tercampak ke luar. Ada mainan dulu kecil-kecil kan. Kat taman permainan ada permainan ni yang nampak awak boleh rasa tercampak, boleh rasa centrifugal force and centripetal force. Okay, we'll take a look at the video.
Imagine swinging a rope around in a circle with a can attached to the end. The can is in a constant state of acceleration since its velocity is constantly changing due to its circular path. Acceleration of the can is caused by a net force acting on the object. In the case of an object moving in a circular path, the net force is called centripetal force or center-seeking force and is always pulling an object toward the center of a circle. Without this force, an object will continue moving in a straight line motion. The centripetal force is the tension on the rope. The centripetal force is equal to mass times velocity squared divided by the radius. As these variables change, so will the centripetal force. An increase in mass or velocity, or a decrease in radius, will result in an increase in the centripetal force. A decrease in mass or velocity, or an increase in radius, will result in a decrease in the centripetal force. A change in velocity results in the largest change in centripetal force. If the rope is cut, the can will no longer maintain a circular path, and it will fly in a straight line tangent due to Newton's first law of inertia. The force of gravity pulls the moon towards the center of the Earth. This pull is the centripetal force keeping the moon in orbit around the Earth. If Earth's gravity ceased to exist, the moon would fly off into space in a straight line. Another example of centripetal force is the force that binds mud to a tire as it rotates. As the rotation speed of the tire increases, the centripetal force will not be great enough to hold the mud onto the tire, and the mud will fly off the tire in straight line tangents. As we saw with the can that was attached to the string, the centripetal force is the force that creates the tension on the string, the center-seeking force. There are two perspectives in this example, outside of the can and inside the can. As Newton's third law states, for every action, there is an equal and opposite reaction. From outside of the can, there should be an outward reaction force to the centripetal force. This center-fleeing force is known as the centrifugal force. The reactive centrifugal force is the reaction force to a centripetal force. The can, undergoing curved motion, constantly accelerates toward the axis of rotation. This centripetal acceleration is provided by a centripetal force, which is exerted on the can by some other object. This is the reactive centrifugal force. It is directed away from the center of rotation and is exerted by the rotating can on the object that originates the centripetal acceleration. If an object is placed inside the can, the object appears to have an outward force pushing it against the bottom of the can and away from the center of rotation. The apparent centrifugal force is most commonly introduced as an outward force apparent in a rotating frame or reference. It is apparent or fictitious in the sense that it is not part of an interaction, but actually the object's inertia. The object naturally wants to travel in a straight line, but the centripetal force doesn't allow this. This type of force is associated with describing motion in a non-inertial reference frame and referred to as a fictitious or inertial force. The reactionary and apparent centrifugal forces are not real forces. The reactionary centrifugal force is a result of the rotation, not a force. The apparent centrifugal force is really the object's inertia. A more accurate definition for centrifugal force would be the lack of centripetal force. The concept of centrifugal force is used to describe the physics of rotating devices such as a centrifuge, centrifugal pump, centrifugal governors, and more. Even though centrifugal force is not a real force, it's commonly used because it's easier to describe the fictional force than describing the lack of the real centripetal force. Pumps that have an inlet near the center of rotation and an impeller that forces water outward against a volute to channel the water to an output away from the center of rotation are known as centrifugal pumps because the water is center fleeing. The centripetal force is not strong enough to keep the water traveling in a circle with the impeller, resulting in the water moving out towards the pump volute. The physics of a centrifugal pump are not based on the imaginary centrifugal force, but the lack of centripetal force.
Okay, thank you for all of you for your time watching my video for this session or this slot 5. So we'll continue our lesson in the slot 6. Please remember, if there are any queries or any question, you can let me know through PM or email towards me, and I will leave you with an assignment in the platform. So any question, you can try to get back to me if you have problem. And that's all from me. Thank you. Have a nice day. Assalamualaikum warahmatullahi wabarakatuh. See you all again. Bye.